we starting from the benzene, we are adding methyl groups, we are adding nitro groups. But these two molecules are not same, right? These two are meta to each other, these are ortho to each other. So that's the differences. So adding on methyl groups, well, you can think of that as a Fourier-Krop alkylation reaction, right? That you can add methyl groups there. Nitro groups is a nitration reaction. So you know those two conditions. But because you've got to do two reactions, what matters is which one you're going to do first. Are you going to do the Fourier-Krop calculation first? Or are you going to do the nitration first? Or will it matter? So that's the question. So let me show you. Let's say you have a Fourier-Krop calculation done. I'm pretty sure that we talked about that may go through the multiple calculation. I told you to forget about the multiple calculation right now. That is some concern that who really want to do reaction done in the lab. But I'm pretty sure that it will be less concern for you than answering question paper. So let's say you got the methyl chloride, aluminum chloride, that makes it very unstable methyl alkyl, swimming can happen, then you get the methyl is pretty bad. Then you need to do the nitration reaction, right? When you do nitration reaction, then the question is, this is the methyl group already sitting on there. The methyl group is activated, which puts also para position to nitro. So when the nitration here is either here or there, it's not going to make this. You got the reagents right, but if you do it in this way, Fourier-Krop calculation first, then the nitration, you're not making this, you're making that. So recognizing reaction that you need is the first thing. But if it's a more than one step, you're going to think about how you're going to do it. Order of the reagents is going to start mattering. So I want you to consider that. So if you want to do this, this is a meta substitution. So that's where you should get it from. So the first substituents, it should be the meta directors. So like nitration to the benzene, you get that. Now the nitro groups are meta directors, then you can get the second groups according to the meta position to here. Well, Book says that if you get the electron withdrawing group sitting on the benzene, the Fourier-Krop calculation isolation doesn't go well. That doesn't mean that it will never happen. You get the lower yield, but you get the products. Now, don't just assume that electron withdrawing groups will shut down the Fourier-Krop isolation or calculation reaction. It's going to take more time. It's going to take more temperatures, but it can happen. Yield may be poor, but it can happen.